I'm Shahram from eBay, presenting the work of our team for machine translation that's located in Germany. Before starting for giving the work that we are doing, let's start about the eBay. The context of our work and how that company works right at the moment today. What you know from the eBay is on just eBay marketplace. That also is usual eBay. That also we are having that. In addition to that, we have also a StubHub. That is the largest marketplace for buying the tickets to the concert, to the sport, and so. And at the same time, also we have the classifieds. That's also 14 brands, 10 brands in 14 countries. That also actually try to help people to find their items in the local communities. And then we have about 57% of international revenue at eBay. And the eBay that we are talking right now about is a bit different from the eBay that you may know from the 1995 that has been funded in San Jose. Right now, we have 85. It is most of the items at the eBay are new items. About 81%. About 2/3 of the items are delivered in less than 3 days, and also 70% of the items are shipped for free. There is no cost for shipment, and also we have 1.1 million of listings. And eBay is actually the true marketplace. We are about 170 million of the active buyers at the moment. We have 70%, as I mentioned. We have international and business international from the whole items. And also 170 marketplaces. And we delivered about more than 80 billion translations per day, including also cache lookup. Then, because of so many translations that ask every day for us. And then the question is that how we are using eBay machine translation at eBay. We have two types of the content. We have the static content that also, the most of the static parts of the web pages that it usually should translate it. We usually provide some translation, some post-editing if this is the new languages with the external vendors. But for the other items, like the dynamic content, it is not possible to use human translations. The data flow is huge and also continuous. And because of that, we need to just definitely use machine translations. And then how we use the translation flow. I just give a most common example. Here we are getting a user wants to search for something from different media, then enter the query here in his own language. And then we got the query, and then we translate it to the target language that we want to find the inventories. We send this translation to the search engine. The search engine finds all items in the target language, let's say English. And then we translate them back to original language. And then the users can see what is the items in their language, and then they can buy or select for the next steps. And it's more general things that happen at eBay, but also we have other use cases. In addition to the user queries and titles, we have item specifics that are part of the table that you provide some name value pairs to be translated. We need also description. We need product reviews. Sometimes we need user-to-user communication, customer service communication, also site localization, thing that I mentioned. Usually you apply post-editing afterwards. And what is the challenges in general that we had at eBay for machine translation that is maybe different from the other companies? Empty at eBay is very mission critical. Most of the translation, especially at least for the queries, we need at more than 99% of the queries should be translated in less than 20 milliseconds. The data is very diverse. The amount of the lexicon size is very big. We have so many names, so many brands, and then we need to translate, and we cannot prune or just ignore none of them. We have a wide range of the data. All data that we have at eBay is user-generated. In addition to that, we need, for example, to know that is the queries, is it the foreign queries that we need to translate, or is the original query that we don't need to translate? Sometimes the queries is ambiguous. We don't know it should be translated. It's in the French or into the English, let's say we say figure, or maybe time is English or Portuguese. The context will be limited, even for let's say for queries, and also even for the title that is the most requested translation. This is only less than 80 characters that we need to provide as the titles, and this is very limited. We always have new products. Every day you see a new products, and then we have to deal with the new products. If there is a new names, and then we have to handle them. If, for example, there is a new name that previously was the usual name, but now is a brand name, we have to be ready for that. The data is, again, noisy and ungrammatical, it's user-generated, and we have so many misspelling. In only 110 million of the queries, we have 334 variants of the Samsung that appeared in the queries, and then we need to deal with all of these type of the noise. In addition, brand is very important. It is causes illegal issues if it translates some, for example, brand names, and then the vendors are really not happy about that. We need to know that, I mean, Apple is just an Apple brand, or is it just as a fruit? And then we need to deal for different things. It is famous ones, but we have so many other things that also cause, like an American Eagle. And we need to know that it is a brand or it is a name. And more examples. I mean, when we go to, not in the brands, also when we go to the polysemous word. The polysemous word also, the problem at eBay is more problematic, and also we have diverse. When you type a pink, we think about a color, or even we can think about a typo. When you think about bolt, there are so many different products. And we have, for example, and famous examples like a ball is a sports or formal dance and so on. A skin is for the mobile phone or for skincare things and so. Then we need to handle all of these problems. And also there are other challenges that is maybe more usual. I mean, for find the right word. Instead of the lack of the syntax, but the lack of the in-domain data, the same as mentioned in the previous talk. And also another problem that we are seeing is that, I mean, the Blue score usually is not a good measure, or necessarily is a good measure to provide the buyers better experience. We need to provide a better correlation with the buyer experience that they buy what they want, not necessarily the Blue scores. And also, again, morphological disagreement when we have the problem with the, especially with the morphological data like Russian or Arabic. What we are doing so far, before, I mean, this NMT, we just use a phrase-based model is all working, and we had already some solutions for the problems. We always use a specifically designed name entity recognitions for highly demand products, and then high GMV ones, and then we recognize this is a brand name or it is a usual name, and so. When we think about the neural machine translation, we also think about a solution that also maybe solve or traditional problem for machine translations. We use for our main production system a traditional LSTM network that everybody knows. I mean, also talked a lot about today. We have eBay neural MT that is designed and implemented in-house. It is based on the TensorFlow, and then we have all usual features that also appeared, and you know it is in the TensorFlow. In addition to that, we have some minimum restraining, we have Bayesian dropout, we have multi-encoder, multi-source implementation. Definitely, we use the back translation, byte-pair encoding, and also placeholders. In addition to that, we had also some specific features that we thought or investigating that it may be helpful for us. We think that at some point that copying mechanism might be useful features, because when we're translating source to the target, there are so many items that it should be translated identically, let's say like brand names. And I thought maybe it's useful. That is also one feature. Actually, it didn't help. We use also dual learning. Dual learning also presented last year in the NIPS, and it was very promising paper. They said that they can learn with minimum amount of the bilingual data, and then we can use monolingual data very efficiently. It was very inspiring for us. We tried to also have this in our model. And also bandit and counterfactual learning is something that also I will give more information later. That's also something that it is in our framework. Other things that also, again, eBay specific is that also guided alignment. And also we had thought, since we are not so much in domain data and we observe some problem in the alignment, we thought the guided alignment might be helpful. And also, as a solution for the previous polysemous words, if you know that what is the category of the item, if I know for the Apple appeared in the title, and this title belongs to the smartphones, then it has some clue for me that it should be translated identically or something like that. And the last item is also domain adaptation. As mentioned in the last talk, also we have the problem, the lack of in-domain data. And because of that, we have implemented different ways of instance weighting. Also, we have used also our own model for putting the word embeddings into as an external signal to give more weight for different translation. It depends on the context. But I'm also going to talk about different things that also we have at our system that is also might be useful for the community to think about that, to have it. It was useful for us. Definitely, you need to use the NMT because NMT is very good. I mean, state of the art and get better results. It's a provide fluent translation, it's integrated training, easier to implement, and all of the things that you know so far. But phrases are also important. We shouldn't completely ignore them. The phrases can capture idioms if it also appeared only once or twice in the corpus. They are good for local reordering, and they are good also for handling of the rare words. And addition also, it's a count-based model. I mean, then this is a different look to the data and solve the transition problems. And maybe having the count-based in addition to the usual or attention-based model, we can get something from the system combination or a better combination of two models. And also we have some features like a text override that is work perfectly for phrase-based. And it's a good feature for us because our language quality assurance team always asking that this term should be translated, and we need to force the system for that specific terms. Because of these things, we decided to try an approach to integrate NMT and phrase-based together. Then we combine them to get better models. We hope that from the first item to get some improvement by just system combination. We also think that NMT has a better control of reordering. Then reordering should be better and keep it as it is from NMT. We won't change it. And also the search space is not limited by the phrase table. Phrase table is limited. We cannot generate anything that we want, but NMT is more general, especially in case of the BPE. Then we think this kind of, we should make sure that phrase base is not a limit. And the last item is also we want to keep our current production pipeline unchanged. We want to have it as it is, the previous items. Only we have another component that is an NMT that we just fit to the model, and then no change in the production. How hybrid approach works for us is that we have a model combination of NMT with phrase-based things. We have the search word over words. Words means that the words comes from the NMT. And also we have the search over the phrases that come from the phrase base. We try to just have two different beams, two different stack that develop the translation word by word. And at some point we try to combine them when all the translation get scored. And the third time said NMT training is not modified. NMT should be kept as it is, and then we try just make it help it. That NMT procedure take over everything. We don't just give some suggestions. And then we integrate phrase-based models indirectly into the search. Then the training of the machine NMT is unchanged. We train first, we converge the model, the first step. We also have a phrase-based, we train the models and we have phrase-based. And then we try to combine them in another optimization for scaling factors. So we expect that the target sentence can be composed of word-based NMT and also phrase-based translations. So the usual formulation for the models is the same as NMT, but we add also some features. We work, for example, we can have external language model, we can have also phrases. We also try to have, for example, coverage penalties to give more, to force the system to, for NMT system to cover more words. That we can discuss it later in the question if we want. How it works. Let's try an example. It's maybe easier. This input sentence is jetzt geht es los in German. I want to translate it. We try to translate from the word beam and also from the phrase beam. For the word beam, just NMT, we got to translation, no and hence for the first word of jetzt. We don't have any offer from the phrase base, for example, here. We just keep it as ongoing and don't change anything. We go for the next item. Again, we develop the translation from the beam search and then find that, for example, the it should be translation that attend to the word get here. When we see that there's a next word that attend to the get, we try to find all phrases that start from the get. Then, for example, we try to find out the phrases that cover get, gettest, or gettest loss. For example, here we find two examples that the translations that gettest loss translate it begins, and also gettest loss translate to it is showtime. What happens? We put these translations into the another beam, and then we go forward for that. When we have two different types of translations, we keep all the hypotheses here until all of them get a score. For example, no, we have the one begins that is not, we didn't get any score from the NMT because we need to get an score to combine it into our log linear models. So in the next item, when we develop the translation, then the focus will be on S. And then we try to, again, get from NMT beam search. This is no, it starts, no, it is, and hence we start. And then no, this translation has a chance to get a score. And then we said, okay, this is a begin should be translation option. NMT get it, and then from the softmax give it some score, and then we can put it here into the first beam. But the next item had not been completely scored, and then it remains here. In the last item also, the short time also gets scored, and then we have some hypotheses. Definitely, we are using pruning here, to separate pruning here and here. Usually what is the name? Threshold would be 12 here and 4 here. We can get good results. Okay, here one of the real example of the translation that we got. As you see in the gray scale, is all NMT approach to get the translation, their attentions. For some of the translations, we got some phrases. We don't use phrases, for example, for translation of the system, because maybe we don't get any offer from the system, or we got offer, but NMT didn't like it, or didn't get a good score for that. Here, we got some score from the translations here, and NMT also approve it and like it, and then we keep it in the system. So this is from the translation, and some of them the translations come from phrase-based. We published a paper in MLP last year. There's so many experiments, how to deal with choosing between the phrase-based and the word-based. What is the coverage? Should we have a hard coverage for the phrases or hard coverage for the NMT? Actually, what happened, we don't have any coverage constraint for NMT, and we have a hard coverage constraint for phrase-based, only for the phrase level. We don't use two phrases that shared some source sentences, so the source words. And then we try to do the pruning, rest cost estimation. Rest cost estimation also other features for NMT. We discuss all of them in the paper. I don't go to the details. I just try to give some examples, some translation result that may be interesting. We are showing here the translation from English to Russian, and then we have a training set of about 2.9 million sentence pairs. The running word is about 46 million, 45 millions. As you see, the vocabulary size for us is very big, about 300K on 700K in the Russian side, because Russian is a morphologic language. And then we have about development set. This is 950 sentences. For the test sets, we try to find a task that is more similar to the usual NMT task, and for the usual formal text, it is or description, translation of an item or a product. And here are results. Here is our phrase-based system that is used in production. And it is actually for the dev set. Maybe better to look at one of the test sets. It's our system in production. Or NMT system outperforms our phrase-based. It is with a large margin. We got some improvement when we moved to the phrase-based. These two systems are completely fair together. To compare them about the same data. And also here, for this production description, we see more improvements when we use these phrases. But here also, we have opportunity to use more also a larger language model. When you use a larger language model, then we can get better results. And it's interesting, if we just use the larger language model and we don't use the phrases, we didn't get in these improvements. These improvements count when we have phrases and language model together. Without removing one of them, we just also lost that improvement. Another important thing, as I said, for us is that we have a language quality assurance in the team, and then we need to just try to deliver high quality, at least for items that is very sensitive. And for example, here we have got a translation, and then the translation here, it is wrong. Here, this Mr. Hitter, it should be one brand name and should be translated correctly, but you see that this is the wrong translation. This is the source sentence, and in the original access is target translations. And also here, the translation is okay, it's not bad, the host assembly, but we wanted to have used our own terminology here. When we use the phrases, then we can also use the previous models. It is different from the placeholders, please note that. We got these two Mr. Hitter and host assembly to translations. These translations should be changed, and then for that we try to give two phrases to the system. For example, Mr. Hitter, we suggest to translate with Mr. Hitter, and for the With assembly also we give another offer that is a better translation at this based on our quality assurance team. And then we give the translations, then it's used in the search, and also NMT find that a reordering of these two is better, got a better score. Then we just provide the translation and that reordering done by NMT. It is what our initial intuition that, I mean, in such a case it should work better. And then we have some example that prove that what we wanted has been achieved by this model. We have another team for the idiom translation that we mentioned. For this example here for the language, we have, for example, fast on a boat, and we don't have a limitless resources. And when we translate with our NMT translation, we got some without soil because it's a rare word, and then that rare word didn't handle correctly. But hopefully, because we have this translation of the, again, idiom, the English, the bottomless pit, this type of idioms get translated correctly. It is offered by NMT and offered by phrase-based, by phrases, and NMT approves that it's a good translation. It would be good to keep it. Another example is for Männerfreundschaften, and this is also a compound word. It is hard to translate. NMT did a bad job here, and also here, again, this hybrid NMT makes a better job. This is, of course, good examples. And this translation also approved by our human translations. At eBay, when we wanted to develop to deploy a new model, we give the model to the human translators. The human translators check that the translation is better. LQA, language quality assurance, check that there is no real problems, and then we put into the deployment. And also this improvement also approved by human translator that is better than our current system. As a summary, what I was saying so far, it is that neural MT also works fine for the state-of-the-art at e-commerce tasks. I said almost because for the Qt translation, we had a problem of the speed. We are trying to make the system faster. And also for the titles, it's okay, but we need to make it better. But for the description, we can also use it as it is. NMT also outperforms a phrase-based production system, as I mentioned. Also, hybrid system also, as I said, it's a very good feature that we wanted. It's very useful for us, mainly because we keep our own pipeline unchanged. And I miss anything? And also, the hybrid approach also facilitate to productionize the NMT models. Okay, what we are currently doing, and I didn't mention here because I wanted to make the talk more coherent and also better. Let's talk about different things. Here, this some data we are doing in terms of the data. We're trying to use a more comparable data in our framework because we have so many comparable data, the same item described in two different languages, and can use a UPC or what is the name, barcode number. I forgot exactly the name. We call it GTIN. I don't remember what is it abbreviated for, but the GTIN numbers. We can just map the two products. And then we can use the source monolingual data as a semi-supervised things, and also using the banded learning, and also learning to translate from the, try to find out better rewards from the buyer experience, from the buyers, that, I mean, what we can optimize the system to do a better job on that. And also we try to use our counterfactual learning. That means that a paper published in the last ACL, if I remember correctly. And here at eBay, we have so much data, but we do the translations. The buyer can see also this is the original text, and then they can rate the translations. And then we have so many of such a feedback, and we want to use this feedback to do a better job. We also use the target monolingual data. Back translation is a very strong baseline. We try also to see that different ways to do that, maybe better for some early experiments with continuous back translation to do step by step. And the last item was the dual learning. We did lots of work on that, and then so far we didn't get good results as reported by the NIPS paper. I mean, we tried really hard to find all of the things. It is hard to outperform a good system using back translation. If we don't use back translation, it can do a good job and then we get good results. But when those data is ready, with back translation, a strong baseline, we were not able to do that. Yes, that's it. Thank you.
Yes, we have time. So it's extremely dense, and it's impressive what you have been doing. The phrase-based, I just have a question. Would it not, could it make sense to integrate the phrase-based constraint decoding for the training too, or you don't think that it would make any difference?
In training of NMT, in training of NMT.
Yes.
My personal opinion, no. I mean, it didn't help because I mean, NMT alone outperforms phrase-based, and then I don't think that the limitation that our constraint that we apply to the phrase-based MT is a good idea to apply to NMT. But I have no any strong scientific reason for that.
Thank you.
I had exactly the same question.
Is there more question from the audience?
It sounds like you have an incredibly tight line of how many seconds you need to return it. You said 20 milliseconds?
For query translation, yes.
So that's like on the fly, you're translating. And can I ask, are you using GPUs to do that in production?
As I said, for query translation, we didn't use NMT. We used only phrases.
Oh, I see. That's only phrases.
And this is one of the constraints that we didn't use NMT so for the query translations, and we used it for other tasks.
So NMT stuff is all happening offline?
For product translation, it's not offline, but I mean we have later. I mean,
it's not on
service
the fly.
level agreement.
Oh, okay.
But for titles, it should be about 200 milliseconds.
I see. Cool.
And also for query translation, we use a cache model. I mean, it is for query. We expect that we don't get so much new query translations. We keep all the translation in the one cache, and then look up.
So we saw that you had some issues with the data quality. For example, the misspelling of the word Samsung. Do you have like some system for the users when they put the data in to like suggest some corrections or to have some better data quality just from the input?
That's a very good question. What I described here is only for machine translation part of eBay. I mean, we use these models in different ways for image to text translation, for image captioning. We also use it for text generation because I mean, eBay also has it. All data that we have is a user-generated data, and we need to provide some static pages that we call a browse node for text generation. And to your question, for spelling correction, also we had another subsystem that is part of the search team, and they give us, they try to find the correct spelling and then give us. But to answer your question, part of the data again handled inside our training data because sometimes we have in the source data for in-domain data we have spelling errors, and then we have the correct translation at the target site, but we don't have anything special for handling of spelling errors. And the detected quality is also an issue for us, and we try to different pipeline for the quality, that sampling and also checking the translation, and so to do a good job. And then we definitely get good improvement when you do a better cleaning.